Like buried treasure, they lie hidden from sight. Echoes of an ancient past, they whisper secrets and tell tales once lost to time. Fossils are remnants or impressions of ancient organisms that are naturally preserved in stone. While there are hundreds of fossil types, they are often grouped into two major categories: body fossils, which are the preserved remains of plants and animals, and trace fossils, which are records of an animal's behavior, such as footprints. Together, they form the fossil record, a primary account that tells the story of life on Earth through stone. Fossilization, or the process of preserving organisms in stone, can occur in countless ways. These methods are largely grouped depending on whether the organisms are altered during the fossilization process. Fossilization that does not alter a specimen can help to preserve its original form and texture. Among many methods, this group includes organisms that have been frozen, preserved in tar pits, and mummified. One special case involves trapping organisms, oftentimes insects, in amber. This process begins when an organism is covered in tree sap. The sap, or resin, forms a protective seal around the entrapped organism. Over time, the soft resin hardens and turns into amber, with the organism suspended within. This process creates a biologically inert tomb for the organism, allowing its soft tissues to be remarkably preserved. Other fossilization methods change the specimen as it is being preserved. For instance, carbonization transforms soft tissues into thin black films of carbon. In fact, countless layers of carbonized plant material create a well-known fossil fuel: coal. But one of the most common types of fossilization that changes a specimen is called permineralization. Permineralization begins when minerals from water or the ground enter the pores of dead plant or animal material. Over time, the minerals attach themselves, clinging onto cellular walls and building a crystalline network in the empty cavities. This mineralization hardens the bone and turns it into stone, thereby preserving its original structure in fossil form. When conditions are right, fossilization can preserve crucial information about an organism. Permineralized wood often contains enough information to identify its tree genus and sometimes its species. Insects encased in amber have been so well preserved that their genetic material was extracted and partially sequenced. And footprints left behind by ancient hominins help paint a picture of what life was like for early human ancestors millions of years ago. With every fossil uncovered, the planet's ancient past becomes clearer, helping shape our understanding of our world today.